All right, guys, let's start today's topic. Today we're going to start the first session of a two-part session. So today we're going to do HyperV. We're going to go through the theory of HyperV and then do a worksheet. And next lesson, we're going to continue on with that worksheet and do the next part. Okay, so we're going to talk about HyperV. Okay, so all of you should have done your 4IVM before you've done this subject. And that explains all about virtualization. Okay, so obviously in that subject, we concentrated on the VMware Workstation, which is a really good tool for the desktop virtualization user. Okay, whereas Hyper-V is more of an enterprise product. Okay, there is a version which is on all Windows 10 client computers that you can install Hyper-V as an additional add-on. So for example, if I open up the control panel here and show you the programs, if we look at Windows, turning on Windows features, you'll see that there's a Hyper-V as part of this Windows 10 that's in front of me. Okay, this is not the Hyper-V we're going to be talking about. The Hyper-V we're talking about is basically the one that's on the Server 2016. So again, if you want to compare what's what, the VMware Workstation will be probably on par with this Hyper-V, which is on Windows 10. Both desktop virtualization. It's really for the person who's sitting in front of that computer to be using it as a way of learning, testing, or just quickly getting something up and running. Whereas what we're talking about is enterprise virtualization. If you want to have something that's comparable to Hyper-V, it's VMware vSphere. Okay, so just like VMware is probably the founder or the biggest virtualization software company, and they have a suite of tools. VMware Workstation, the desktop virtualization tool for the desktop user, and VMware vSphere, which is the enterprise virtualization for the enterprise, which is on par with what we're talking about today. When you go to the diploma, you'll do another subject all about virtualization. You'll learn a little bit more about Hyper-V. So today what we're going to do is some basics of Hyper-V. Okay, some overview of Hyper-V and basically using the Hyper-V for virtualization in a pretty basic level. So today's objectives is to give you an overview of virtualization technology. Some of it will be a bit of a review, but really we're going to concentrate more on the reasons an enterprise would like to virtualize rather than what a person individually would like to virtualize. In our worksheet, we'll implement Hyper-V, but it'll be a little bit funny because the worksheet will tell you to install Hyper-V into a virtual machine which is running on VMware Workstation. So it's a virtualization tool that's inside of a virtual machine which is being virtualized by VMware Workstation. And eventually we're going to create another virtual machine which is in Hyper-V that's inside of VMware and so forth. Yeah, that's a good point actually. If you do have VMware Workstation installed on your computer and then you put Hyper-V on it, then they can't coexist. And that's a very good point. Okay, it's not, and then the reason why we're doing it is not because of that reason. Okay, the reason we're doing it is because of the fact that we use VMware to virtualize Server 2016. Okay, obviously you know the actual operating system on these computers is Windows 10. We're not going to tell you to go scrap Windows 10 and put Server 2016 on the actual hardware because that just impacts on everyone else who uses the room. So what we have to do, the easiest way for us to teach it, because we don't want to scrap the hardware, is to actually virtualize the Server 2016, then install Hyper-V inside of there, which then installs a virtual machine inside of there. So it's what's called a nested virtualization. Okay. We'll manage the virtual machine storage and the virtual networking. Okay, so just to a basic level. Like I said, there's another subject all dedicated to virtualization, and we'll look at Hyper-V in a lot more depth. So let's actually look at server virtualization. Okay, so here's some benefits if you weren't sure about these. Obviously, it should be a little bit of a review from your 4IVM subject. So obviously, the benefits of the virtualization with Hyper-V is the same as virtualization with most virtualization softwares. Okay. So first point is it's invisible to users. So it doesn't matter if we have a physical server or a virtualized server. Okay, so in the enterprise, instead of having a physical machine per server, we could potentially have a few Hyper-V servers and have all our different servers virtualized. Okay, and as far as the user is concerned, you wouldn't have no idea if it was a physical server or a virtualized server. Just like right now, we've all walked into this room and we're all logged in with our username and password, and that was sent to our domain controller on the TAFE domain. But was it a physical machine or was it a virtual machine? Do you know? No. Do you care? Not really. The point is, it doesn't matter if it's a physical machine or a virtual machine as long as it can do its job properly. And there's so many benefits of it being a virtual machine that it outweighs any possible problems. Okay, so it's invisible to a user. Another advantage is that the guest machines can be a different operating system. Hey, let's just say we have a piece of software. This software that one of our developers created that needs to be hosted on a server, that is only compatible with Server 2003. All our servers are actually 2016 now. What do? Do we build a physical server that's 2003? Well, that just seems like a waste, doesn't it? So why don't we just virtualize a new virtual machine and install Server 2003? It doesn't take up a whole physical machine. It just is a little virtual machine. We put this program on it and it can function away happily in its native operating system without worrying about emulation or some sort of compatibility mode or so forth. And what's even more impressive is, what if that piece of software can only run on a Linux operating system? Oh, we've all only got a Windows environment. Oh, we don't want to actually install Linux on a physical machine. Here, maybe we just create a virtual machine with Linux. Okay, so it can be a different operating system. It's a more efficient use of hardware. So if I see some of you guys with laptops, looks pretty impressive. So like if you think about it, you probably went out and bought that laptop thinking, oh, I've got this much money to spend. What can I get? That's the maximum I can get, isn't it? Usually that's the case. You don't think about how you're going to use it every day. You don't think about, oh, most of the times I'm going to be checking email, browsing the website, and maybe like, just doing instant messaging or something like that. But you're thinking, oh, when I play that latest release of that game, I need this, this, and that. And you go off and spend your $3,000 or more buying the best laptop or computer you can get. And what ends up being the fact is that 90% of the time, you're probably using only 10% of the resources. Okay, and that's the same with servers. Okay, you go out and buy a physical server, but as we all know, most of the computer, for example, my computer right now, I know it's only a desktop computer, but I am running this desktop computer. I've got my email open. I've got my Skype for Business open. I've got my PowerPoint open. I've got a few websites open in my browser. And look at it. If we look at my CPU, it's if apart from that spike, and that spike is probably usually the case when you launch something new, but you can see it's probably less than 10%, isn't it? Or 10%. Okay, that's not. Look at my memory. I've got 8 gigs here, but that's not too much. But I'm only using like 1/3 of it. If I look at my disk activity, again, I've got a solid-state hard drive. It's got a certain level of performance, and really, right now, I'm not using much of it at all. Same with my Ethernet. If you look at my Ethernet, you can see that even though I'm accessing the network to some degree, I am not really using the full capacity of my my network. So if you look at this, it's a gigabit network, but I'm only sending 680 kilobits and receiving 8 kilobits or 24 now. So it's fluctuating, but that's not really at all the capacity of my network card, is it? So what I'm trying to say is that most of the time our physical hardware isn't being wasted. The resources are being wasted. It's not like you get a discount because you're not using the CPU or the memory or the CPU or the network card. You pay for it regardlessly of how you use it. So if I just paid $3,000 for a system that is so great and so good, but only end up using 10% of the resources, it's a bit of a waste of the hardware, isn't it? And the advantage of virtualization is that I can stack multiple virtual machines basically on the same piece of hardware. So if each one uses about 10%, I potentially could put 10 different virtual machines on that same piece of hardware, 10 different operating systems with their apps running. And then I'll use up my resources and get more bang for my buck. So instead of buying those 10 physical machines for $3,000 each, 30,000, I'll spend $3,000, buy the one piece of hardware, and virtualize 10 servers. Okay, obviously that's not ideal. We would at least have 2 or more physical hosts for various other reasons, but just theoretically, for actually running the 10 servers, I could end up with one machine. Okay, and obviously that's only giving an example of my computer, which has only got 8 gigs of RAM, 1 CPU with it's only an i5 CPU quad core, and 1 gigabit network card and 1 hard drive. When we're talking about virtualization on an enterprise level, we're talking about a host with multiple network cards, multiple CPUs, 128 gigs of RAM potentially. Okay, and obviously that just means we can host more and more different virtual machines on there and do more and more work. With virtualization, there's also service and application isolation. What does that mean? That means that if we had physical servers and I wanted a DHCP server, and I wanted a web server, and I wanted a Active Directory server, I can put them all on one server. That's fine. But they're all on the same server. So if someone compromises the web server, they could then be using that way in to compromise the Active Directory, which means, hey, guess what? Your administrator password is there in Active Directory, isn't it? Can compromise your DHCP server, can compromise every other service that's running on the same operating system. So when we have service and application isolation, we can actually easily, instead of having one server that does everything because we have a physical server, we have a virtual machine that is the web server. We have another virtual machine which is a domain control. We have another one with DHCP and whatever service that we want. And that way, if one is compromised or one is actually being used, it doesn't affect the other ones. Okay, even if it's not a hack, it could be just a compatibility issue of running web server and Active Directory, or web server and the database, or something like that. Okay, so we isolate them so they're not interfering with each other for security as well as compatibility and workloads. Then finally, the workload consolidation. Like I said, we only use 10% of our hardware, and when we consolidate all these workloads, we are saving money as far as how many pieces of hardware we buy. We certainly won't need as much as if they were all physical hardware. We certainly need more than one HyperV server in a well-planned enterprise-level virtualization environment. Definitely, I'm not saying you only need one computer. I'm just saying for the amount of physical computers you can have a lot more virtualized computers. What is Windows Azure or Microsoft Azure? You probably heard of. Basically, that's Microsoft's cloud services. Okay, you probably heard of the cloud quite a few times. There's a few other ones. Obviously, this is a Microsoft course, and we're going to talk about Microsoft products. But to be honest, there's Amazon Web Services, there's Google Cloud, there's obviously Microsoft Azure as 3 of the biggest ones, and there's many others, many others. There's actually a few local ones. For example, locally in Adelaide, there's an Innerbox. In Western Australia, there's ZetaGrid, but they all provide some similar services. Okay. So when we're talking about Azure, a lot of it can be almost transferable to all the other providers as well. So Windows Azure is a cloud-based platform for hosting virtual machines and applications. So there's different levels of the cloud. Okay, obviously we all are familiar with the cloud in somewhat because we all probably already use the cloud whether we realize it or not. For example, we use Office 365 here in TAFE. All of you guys have access to TAFE's Office 365 subscription, which gives you Office 365 to be used on your computers, and it gives you Outlook on the web. It gives you all the different apps on the web. It gives you OneDrive on the web. Let me just quickly show you this. Okay. So if I go to my Outlook, online, this is an example of Office 365, which is what's it's called software as a service, or SaaS. And on here, I can actually launch mail, calendar, Word, PowerPoint, Excel, all running in the cloud rather than on my local machine. And I can obviously install Office 2016 as part of this to my local machine. And if you were a student, you're allowed to install it a few times on a couple of different machines. And as long as you're a student here, you're allowed to keep on using it. We also got OneDrive. Okay, OneDrive, which is access you get as part of being a TFSA student, and this is online storage, which synchronizes across all your computers with the documents you want to use. So that's an example of software as a service. Okay, and a lot of people already use that regardless of whether they know it or not. If you have an iPhone, you back up your iPhone to iCloud, same thing. If you use Google Apps and Google Docs, then that's again software as a service. There's also platform as a service. Okay, so besides using these apps for a browser, like what I've been saying, there's platform as a service. For example, I have a website. This website needs an SQL database. This website needs a .NET framework. I don't want to administer a whole virtual machine to have this web server. Why don't I just buy a platform as a service account from a Microsoft Azure and actually put my website into an environment where there's a SQL database, a .NET framework, and then it will just be hosted in the cloud and people go to my website. That's what's called platform as a service, or PaaS. And finally, probably what we're talking about here is what's called infrastructure as a service, where you can actually fully virtualize a whole operating system and the virtual networking as part of it. And the great thing about the cloud is that you pay for what you use. Okay, what does that mean? It means that, hey, if you actually want to have your own servers and so forth, you go out and you buy those servers. Whether you use 1%, 10%, 100% of those hardware to the extent of 1% or 100%, you pay for the full amount of that hardware. If that hardware costs you $10,000, you pay for that $10,000 regardless of how you're using it. Whereas if you're using a cloud provider like Microsoft Azure, you pay for what you use. You use this. You use a certain amount. You pay for that amount. You're renting the space. You're renting the resources. So, perfect example of that is if you actually developed an app called Pokemon Go, for example. Okay, we know right at the start there were some problems because there were so many people wanting using it, they couldn't keep up with the demand. It just exploded. So basically, if they were being hosted by their own servers and their own hardware, they would never even be able to keep up with that demand. They couldn't even order the hardware and get it shipped over in time because of the demand was so hot and high. So if they were in the cloud, they could just scale up really quickly because they already got the hardware there. You just pay for more because you're using more. And just like anything, well, we all know that Pokemon Go was really, really popular at one stage. What's happened since? So sort of like gone off the radar a little bit. Okay, people are not so interested in it. And now what? If they went out and bought all that hardware to cope with that maximum demand, and now people are not using it as much, that demand is shrinking. And guess what? They're left with all that hardware, potentially, that's not being used. So you'll never get your money back on that if you actually went that. So if you actually use the cloud, because you pay for what you use, you scale up really quickly and you can scale down really quickly. Okay, and you pay more when you use more, you pay less when you use less. So you can increase and decrease capacity automatically and swiftly. Swiftly is very quickly. So you can use Windows Azure to host websites, production applications, or full-on virtual machines. It can be used as a proof of concept to get things up and running really quickly, to show your bosses that it works. There's, like I mentioned, there's desktop virtualization. Desktop virtualization includes the following technologies. There's client, local HyperV, which is basically what I showed you before on my Windows 10, and you can use that to virtualize machines on your desktop computers. There's also VDI. If you've ever heard of this term VDI, it's a virtual desktop interface. What does that mean is that instead of actually having a full desktop computer on your in front of you, instead of having RAM, instead of having CPU, instead of having all these things on a full desktop machine, we have what's called a thin client that allows us to connect to a virtualized instance of your desktop. And so therefore the processing, the CPU, the storage, and all that kind of stuff is hosted on the server. Remote FX allows virtual machines to display a rich graphic video capabilities. A Remote FX requires a GPU that supports DirectX 9.0C or later, and also a CPU that supports SLAT. Presentation virtualization. So difference between desktop virtualization, presentation virtualization is that desktop virtualization, the user assigned their own virtual machines that are running a client operating system. So each user gets their own virtual machine, okay? Their own virtual machine with operating system. The desktop and apps run within the virtual machine, so just like what we know. But presentation virtualization is that a user signs into a separate session on the server. This is more like your remote desktop, okay? Remote desktop services. The desktop and applications run on the host server. So presentation virtualization include remote desktop services, full desktop with RDC, application using remote app, and remote access through RD gateway. So what is HyperV? HyperV is Microsoft Windows Server 2006 with virtualization, okay? Is the hardware virtualization role that's part of Server 2016. It gives virtual machine guests direct access to the host hardware. It's compatible with Windows Server Operating System 2016, full GUI, Core, or Nano, if you remember Nano Server. To be honest, the best way to run Hyper-V is probably on that Nano server. Because really, when you're a Hyper-V server, you don't really need the GUI. You don't really need anything more than just the virtualization part of that system. Okay, so really we can manage it from another computer, but all the resources, if we're using Nano, goes towards the virtualization hosts rather than the actual host operating system or graphics on it. So Microsoft Hyper-V Server 2016, the hardware requirements, factors to consider when planning a hardware server for running Hyper-V. So the processor characteristics. I know it's probably pretty hard to find, but I'm sure if you had to use some older hardware, you must have a 64-bit CPU. You must have hardware-assisted virtualization and that data execution protection. And pretty much, if you buy a new PC, that's all going to be there. But if you're trying to test this out on an older PC, you might get a, Intel Core 2 Duo or something like that. You might have one of those sitting around. You want to install Server 2016 on there with Hyper-V. It may not have a 64-bit platform. It might not have that hardware-assisted virtualization, or even if it had it, have it turned on. We all know that, don't we? From 4IBM, that you know when you buy a computer, just because you got hardware-assisted virtualization doesn't mean it's turned on in the BIOS. Okay. The processing capacity. Another thing to think about is if I'm buying this piece of hardware to be a Hyper-V server, if I want to virtualize lots and lots of different virtual machines, my processor or CPU capacity must be pretty high. Is one CPU enough? Or should we get 2, 3, or 4, or even more? Okay, there's many different hardware vendors now that can actually get you lots and lots of these servers with these capacity. What about memory? You know that when we actually create a virtual machine, we allocate that amount of memory. And if they're running, they are using that amount of memory. So therefore, the more memory we can have on a virtualization server, the better. So how much memory do we have? What about the storage subsystems performance? We all know in class that, hey, we've been talking about solid-state hard drives, haven't we? Since probably last term. That we know that if we have a normal mechanical hard drive and we try to run more than one virtual machines on it at the same time, we know that actually the performance gets really bad. So therefore we buy a solid-state hard drive. But when we're talking about Hyper-V server, where we're running lots and lots of virtual machines on it, again, what about the storage? Are we even going to be using local storage? Okay, so thus far what we've been doing in class is always been putting things on the local hard drive, on the local machine, or in a portable hard drive which is plugged into the local machine. And you know what? If it's actually stored locally, what if that piece of hardware fails? What happens to all your files? It's gone. It's not so much important the files are gone. The thing is we can't recover that virtual machine to be running again, isn't it? So therefore, maybe when we're talking about storage subsystems for Hyper-V or virtualization software, we actually look at, instead of storing everything locally, we actually store it on another computer. Okay, what's the best thing about that is if it's stored somewhere else, if I have a Hyper-V machine, I can just run it from that place, store it somewhere else, but run on my Hyper-V. But if this Hyper-V, let's say, failed because the power supply died, I turn on another Hyper-V machine. The files are still there on the storage server, and I can open it up again and turn it on again, can't I? Easy peasy recovery. So basically, when we're talking about storage subsystem, we're talking about shared storage, a centralized storage in the form of a SAN. Okay, that SAN could be using any of the hardware vendors. Probably will sell you a SAN of varying performance and capacity. But basically, these storage, if we want the SAN to actually be able to perform well enough so we can run all these virtual machines that's stored on them, they have to be a high performance. What about the network throughput? So don't forget, when we are actually virtualizing these servers, they're actually servers, aren't they? We're going to have loads and loads of clients who want to access these services. So can they actually access the services if the whole Hyper-V server only had one network card, which was gigabit? And if there was 10 virtual machines running on it, it's effectively, each one is actually getting 100 megabits. And what if one of the servers is really busy? It could be hogging all the bandwidth, isn't it? So therefore, the other 9 could be getting a lot less. So basically, maybe instead of having, and besides just for the virtual machine traffic, there's also management traffic when we manage the Hyper-V. What about the storage? We said the storage was stored on a storage area network. What about the communication between the Hyper-V and the storage server? That's through the network, isn't it? So again, we've got all these different types of traffic. Can one network card actually handle it? Or do we need to have more? Don't forget there's such thing as NIC Teaming, which is the ability to team lots of network cards together, and they would actually work as if they're one network card and share the different communications. So effectively, if you have 2 network cards at gigabit, you get 2 gigabits. 3 gigabits. And you can even allocate different networks for different actual purposes to actually break up the amount of traffic that's used. So virtual machine hardware. So when we create a virtual machine in Hyper-V, it actually comes up with a virtual hardware. We all know that. That's same as VMware, isn't it? But these are what's actually the actual guest operating system sees. It sees the BIOS, sees the memory, sees all these things, and you can add the following hardware to a virtual machine. You can have SCSI controllers, network adapters, and so forth. So hopefully you're aware of that, because at the end of the day, this hardware is what the guest operating system sees. So therefore, the guest operating system will have to install the appropriate drivers to use them, right? In your experience of virtual machines, have you ever had a situation where you needed to download a driver because something didn't work properly? No, I don't think so. But in physical hardware, did you ever have a situation where you install operating system, something didn't work because you didn't have the drivers? All the time, right? So therefore, that's one of the benefits, another benefit of virtualization. It gives you a virtual hardware that's totally independent from the actual physical hardware, all except for probably the processor, okay? So therefore, it doesn't matter if you've got a Realtek network card or wherever, you don't need the drivers for it in the physical world. You just get a network adapter that's in the virtual world, which is actually a assured computing environment. That's what VMware calls a ACE, assured computing environment, meaning that you'll always have the drivers for it in the operating system. What is dynamic memory? The word dynamic means changing. Okay, memory is the RAM, isn't it? So dynamic memory is changing amounts of RAM. So if you look at this page, you can see that this virtual machine has been configured with, let's say a gig. Oh, sorry, more than gig. 10 gigs of RAM. 10 gigs of RAM as the maximum amount of RAM. but the minimum RAM is only 512 megs. What does that mean? It means that the memory of this virtual machine can range between 512 megs up to 10 gigs. If you look at this, this is a startup RAM. It's 1 gig. So during startup, you probably need RAM a little bit more because you're loading stuff up. But it's dynamic, meaning it ranges between those things. And when we're talking about this, we're not talking about how much RAM the virtual machine sees, because they'll see whatever amount of memory you say it's got. Okay, if it says if you have allocated 2 gigs of RAM, you'll see 2 gigs of RAM. This is talking about actual physical memory on the server. Because you know what happens when a server runs out of physical memory, because there's more things that needs to be loaded in memory than it has physical memory for. Do you know what happens? Page files, which is a form of virtual memory, okay, which is actually part of the hard drive, which actually is being used to store things that doesn't fit in the memory. And what's the difference between the speed of the hard drive versus the speed of memory? Which one's faster? RAM is significantly faster. So therefore, when we're talking about what's a page files or virtual memory, that's going to lead to a very slow machine. So basically, this dynamic memory means it fluctuates between these two amounts, minimum and maximum. Minimum is a minimum reservation, maximum is a limitation. But basically, it also depends on what the host has got available to give. There's also virtualization, synchronization, what's the integration services? So you guys should all know what is VMware tools, don't you? What does it do? Yeah, more responsive. What else does it let you do? Some of you guys probably would be using it all the time. Copy and paste files from the host machine to the virtual machine, or synchronize time between your host machine and virtual machine, and a whole heap of things you don't even see. Okay, for example, I can shut down the computer cleanly by just clicking the shutdown command from VMware. I can actually, recognize if the computer is down and so forth. But virtual machine integration services is VMware's, it's HyperV's effectively VMware tools. Okay, so it's obviously not called VMware tools because it's HyperV. It's called integration services, but it does the same thing. It allows us to shut down the operating system without actually going into the operating system and clicking start and shut down. It allows time synchronization between the host and the virtual machine. There's data exchange, which is your copy and paste. Okay. There's a heartbeat. Okay, I'll talk a little bit more about that in a second. And also there's a backup for volume snapshots. So the heartbeat, getting back to the heartbeat. If we've got a system where we've got 10 different virtual machines all running, and how do we know? The problem is when these servers are running, they're great. What if one of the servers actually crashed, had a blue screen of death, or something like that? How would we know? Unless we're looking at it and interacting with it all the time, we wouldn't know until someone calls up and says, "Hey, your web server is not displaying. It's not hosting the website that you said it was there." And that's when we actually look and see, oh, there's a blue screen. Sorry guys, I'll just reboot this web server and you'll be up and running again. But the problem is we don't want that to happen. That's the worst way to find out you've got a problem. That just shows that you're not very proactive and that you're going to get a whole heap of customer complaints. So what a heartbeat is, just like a heartbeat on a human being. So if you see someone on the ground, yeah, just not responsive, what's the first thing you should do? Yeah, check if it's still alive. If they're still alive. And how do you check if they're still alive? Yeah, so basically you can feel for the pulse on their wrist or on their neck, and basically that's seeing if they've got a heartbeat. Okay, so that's how you check if a human being or even an animal is alive. But a heartbeat on a computer is like that. It's basically this beacon that says, "I am alive, I am alive, I am alive." It's telling someone, okay? And obviously if it's a virtual machine, it's going to tell the host, "I am alive, I am alive, I am alive." And the good thing is I don't need to actively monitor it. I don't have to sit there and look at it and say, "Oh, it's alive, it's alive, it's alive." I can, the host or the systems that we have in place will monitor this heartbeat. And as soon as the system, if the system crashes, like we said, had a blue screen, it's no longer going to be sending "I'm alive, I am alive," and therefore, if it misses several heartbeats, instead of waiting for the customer to complain about the service not running, it will set off a trigger alert or alarm to me to say that something's gone wrong, or it could even be configured with automatic response where the virtual machine gets restarted on another host. Okay, so therefore, hopefully, it restarts the server on another host, and before even the customer realizes it's a problem, it's actually being fixed. You know that sometimes it just needs a reboot, don't you? When you just have a blue screen or something like that, and that could be just they're not getting the heartbeats, restarting the virtual machine on a different host, and the website which is being hosted by that server comes online, and the customer who was clicking refresh, probably before they even hit the refresh button, it's working again. So that's what the heartbeat is. Okay, virtual machine start and stop actions. So there's some possible automatic actions. Some of the possible automatic actions include nothing. That's not an action. That's just leave it alone. Be nothing. Another action could be automatically start if it was running when the server stopped. Okay, so basically, what does that mean? That means if a virtual machine was running before the server crashed or something like that, start it up again. Always start this virtual machine automatically. So regardless of whether this machine was running or not, when this server starts up, this virtual machine would be turned on. Possible automatic stop actions. So if, for example, if you're going to stop this machine, or if you're going to this host was going down, if the physical Hyper-V host was being shut down or being restarted, some possible automatic action could be save the virtual machine state. So pause it, or turn off the virtual machine, which means power, just rip the power off, or shut down the guest operating system, which means to shut it down correctly. Actually start a shutdown procedure and let it shut down properly. What's new in Hyper-V 2016 as opposed to some of the previous ones? So some of you guys might have experience in Hyper-V from elsewhere, but here's some differences. There's what's called Windows PowerShell Direct. So hopefully you guys are aware that PowerShell is a scripting command line language. Okay, so we enter commands at a PowerShell prompt and we get actions, right? But with Windows PowerShell Direct, it means we don't have to be on the Hyper-V virtual machine to execute the PowerShell. So we don't have to go in to a virtual machine console, open a PowerShell command prompt, and enter the commands. We could actually be just on any computer, and we can actually execute this PowerShell Direct and have it execute inside the virtual machine that's running in the Hyper-V. There's a VM configuration version and format, and that helps definitely with the actual having virtualizing domain controllers and using snapshots in production, and we'll talk more about that in the future. There's also rolling Hyper-V cluster upgrades. So when we talk about cluster, it's basically a whole heap of machines doing the same job. Okay, and when you go on to the next level of virtualization, we'll create what's called a Hyper-V cluster. So rolling Hyper-V cluster means, what if we're going to upgrade these servers? Okay, let's say there's a new service pack out for all of the Server 2016s, and we need to upgrade it. Instead of upgrading all at once, because if we actually turn off, with these upgrades, we probably have to restart the Hyper-V machines. So if we did that, all our virtual machines which is being virtualized will have to be turned off, and then we'll have complaints from our customers. Oh, why is your web server not running? Why is that? Why can't I log into Active Directory? Why? All these potential problems if we had to turn off all the virtual machines because the host machines was being turned off. So what rolling upgrades allows us to do, if there's 10 Hyper-V computers in a particular cluster, instead of turning all 10 off and doing upgrades at the same time, I'm going to do one at a time, or two at a time, or three at a time, depending on what capacity they've got. So in this 10 physical Hyper-V machines, if we're hosting 100 computers and we've got capacity to host 20 computers, maybe we can actually turn off half of the Hyper-V machines and upgrade them at a time. Once they are upgraded, we turn them back on, move the virtual machines which are running on the other 5 to the 5 that's just been upgraded, and upgrade the other 5. from now on. Do you get that, guys? So with Hyper-V, we've got what's called live migration, which is actually moving a virtual machine while it's running. Okay, moving its physical location. The integration services has been improved. Hyper-V Manager has been improved. There's also what's called a Linux secure boot, so which means that we can have virtual machines which are Linux, but unlike the Windows machines that in previous, which had secure boot, which means not anyone can just boot it. Linux secure boot allows us to secure who can actually turn on this Linux virtual machine. There's what's called shielded virtual machines. So basically, it's like a firewall for a particular machine, virtual machine, and therefore this virtual machine might be isolated so that traffic to it doesn't affect other virtual machines, or it's protected. Okay. There's also the REFS, or Resilient File System improvements, and the REFS has actually been designed with Hyper-V or virtualization in mind. There's the improved discrete device assignment. There's a new thing called containers. So instead of having a full virtual machine, we could have a instance of a container which is actually shares the same kernel as many other containers. Okay, if anything, it's like instead of virtually a full virtual machine, we are actually just creating almost like the idea of the link clones. Okay, link clones in a production world. We have a hot add memory and network adapters. What does that mean? Hot means while the machine is on. So what does that mean? That means we can increase the amount of memory on a virtual machine or increase the number of network cards on a virtual machine without actually having to turn it off, which is quite good, because one of the worst things about running servers that you can do is turn servers off. When servers go off, services go off, and then you have clients who cannot access services. And if some of these services are making you millions of dollars a year, then by turning them off for 5 minutes could cost you money. Production checkpoints. So the idea of checkpoints is the same as snapshots that we know from VMware. So production checkpoints means we can actually, in a production environment or a full-on usable environment, we can actually use checkpoints to revert virtual machines back. Okay, in the past we've had checkpoints, but they weren't recommended in the production environment because they actually did what's called time traveling. When you time travel, you could actually lose synchronization, especially if it's meant to synchronize with many other servers. And obviously, new in Server 2016 is the Nano Server, which is even more smaller footprint version of Server 2016. And if we put Hyper-V on that, we're really saving resources only for the virtualization needs rather than for the operating system or the redundant needs of the operating system. Virtual hard disk. So with the Hyper-V, virtual hard disk has a VHD or VHDX format. VHD is a generation 1 virtual machine, whereas if you see a VHDX, they're generation 2. What does that mean? They have these as extensions of their files. Okay, just like we have executable file with a .exe, we have virtual machine virtual disk file with VHD or VHDX. The disk can be larger, so the virtual hard disk can be larger. It can go from to 64 terabytes instead of the old 2 terabytes. 2 terabytes is still huge for a virtual machine, okay? But 64 terabytes is obviously even larger. The disk is less likely to become corrupt, okay? The format supports better alignment when deployed to a large sector disk. The format supports large block size for dynamic and differencing disks, and we'll talk more about dynamic and differencing disks in the future. But basically, dynamic disk allows the disk to grow and shrink. Differencing disk is basically storing the difference between one disk and another disk, just like the ideas of snapshots, where you have a snapshot, that disk is frozen, any changes is created on a new disk, and that's what's called effectively a differencing disk. There's also shared virtual hard disk can be used by many virtual machines at the same time. Storage quality of service allows you to limit the hard disk IOs per second. So if you remember, we had a discussion about IOs per second being the measure that's the most important for hard drive or storage. And IO is input output. Per second is how many input outputs it can do per second. How many things can it do per second? The more virtual machines you have, the more IOs you might have to send to the disk. So obviously, if some virtual machines are more important than other virtual machines, we might give them a higher limit, whereas a less important virtual machine might have a lower limit. So that's that quality of service. SMB free, server message block free. So when we actually share a folder or file in our Windows environment, it's actually sharing it with SMB, server message block. SMB free is obviously version free, and obviously this is not the typical shares we have when we share a folder. SMB free can be used as shared storage. Remember we said we have a shared storage where our virtual machines are stored on another computer, and it could be shared to all the Hyper-Vs through SMB free. So the following are some features of SMB free which makes it very good for using in a virtualized environment, and it's highly available. So SMB transparent failover. So basically it can fail over from one SMB to another SMB without the Hyper-V server even needing to worry about it. Okay. SMB scale out. So basically scale out, the difference between scale up and scale up is that when you scale up, you're actually just getting a bigger thing. For example, instead of when you have a scaling up, you're getting a bigger server maybe. Scaling out means that instead of getting a bigger server, you're getting more servers, which means instead of having one big server, you're going to have several smaller servers, but you're just increasing the number. So obviously that is in a lot of ways better because you're distributing the load across all of those things. And if one fails, it doesn't take your whole thing out. SMB multi-channel, SMB direct, SMB over RDMA. There's SMB encryption. Basically, we all know, hopefully we'll know what encryption is. There's volume shadow services for SMB shared files as well. Let's talk about the virtual disk types. So a fixed disk type is basically what we know as when we create a virtual machine, we allocate the disk straight away. That's fixed. That's fine. So if we had a disk, if we had a fixed disk and we made it 600 gigs, but even though we're using 100 gigs, the size of the disk is still 600 gigs because we've allocated the disk space straight away, and that's equivalent to a fixed disk. You guys with me with that? Where we have a dynamic disk is like when we don't allocate disk space straight away. So basically, we might give a virtual machine a 600 gig disk, but because we're only using 100 gigs of it at this point in time, the size of the disk is only 100 gigs, even though 600 gigs is allocated. Dynamic is given through dynamic disk. What does that mean? Yeah, it's actually use up only the space it needs, but it can grow up to 600 gigs. Okay, which is better as far as storage use is. That's why in the classroom I always tell you guys to not allocate disk space straight away, because if you do, you end up with a big size disk even if you don't need it. Okay, but there are advantages with fixed size disks. Because it's fixed size, you can guarantee that the space is going to be there, whereas if it's dynamic, where if the actual physical, there's no more physical space, you won't ever get the 600 gigs even if you've been if there was no more physical space. Managing virtual disks. So the following are maintenance operations you can perform on a virtual disk. You can confirm a fixed disk to a dynamic disk or vice versa. So in Hyper-V, we can go back and forth between the two. We can convert a VHD to a VHDX or vice versa. So going from generation 1 to generation 2 or back. We can shrink a dynamic disk, or we can expand a dynamic disk. Okay, so not the fixed disk, but dynamic disk. So shrink it means adjust it to be smaller, expand, adjust it and make it bigger. Differencing disks. When using differencing disks, you can reduce the space that's used by storage, but at the cost of performance. Okay, so when you have differencing disks, it reduces your performance. You can link multiple differencing disks to a single parent disk. You cannot modify the parent disk, that's like frozen in time, and these differencing disks store the differences. You can use the inspect disk tool to reconnect differencing disks to a missing parent. So checkpoints, same idea as snapshots. A checkpoint is a static image of the data that's on a virtual machine at a given moment. Checkpoints is not a replacement for backups, even though a lot of us would like to use it as a replacement for backups. It's not. It's just another way of recovery. Okay. You can perform a virtual machine export of a checkpoint. So you can export a virtual machine. When you create a checkpoint, the Hyper-V writes a differencing virtual disk. So basically, when you create a checkpoint, the parent disk becomes frozen, and any new data is on a differencing disk. When you apply a checkpoint to a virtual machine, the virtual machine reverts to configuration as it existed in that point in time. So it's a point in time capture of what your virtual machine data, configuration, state, and everything. Okay. If we look at this is an example of what a checkpoint is. I'm sure you guys all have a good idea what checkpoints are, but here we have a original virtual machine. And on Monday, we create a checkpoint. No problems. Tuesday, we create a checkpoint. So a checkpoint's made every day, but on Tuesday, you realize, darn, I made a huge, massive error. I've done this, or that, and now it's completely destroyed. Guess what? We can actually just revert it back to the Monday checkpoint and continue on making checkpoints every day. And I've just pretended Tuesday didn't exist. That's good and bad. So we were obviously able to recover from that big error that's on Tuesday, but we would have lost anything else that's done on Tuesday as well. The local area network. When you use a virtual local area network, you can logically segment the traffic running through the same physical or virtual networks. So we can use VLANs, if you've ever heard of those. Okay, so if you haven't, when you do your Cisco, you'll learn more about VLANs. VLANs or virtual LANs exist on physical switches as well as virtual switches, and basically they take a switch and they say, hey, this switch is all one LAN right now, but we don't want one LAN, we want two LANs, so we virtually separate the switch and the ports. So if we have VLANs in the physical environment, we could take that into the virtual environment as well. So we can actually configure a virtual switch in our virtual environment to have VLANs as well, and configure tagging on each virtual switch and tagging on each virtual network. And basically when we actually tag traffic with a particular VLAN, only other computers or virtual machines on that VLAN can see that traffic or get that traffic. Okay, so basically in order for us to have VLANs from the virtual world and the physical world come together, these physical network cards has to be connected to a physical switch port, which has been configured as a trunking port. And you'll learn more about trunking ports in your Cisco subjects and also in our virtualization subjects in the future. Virtual switch extensions. So virtual switch extensions, so the term extension is something that you can add to it. Okay. So like if you want me to give you an example, your tow bar is a car extension. Why? Because it allows you to add extra functionality to your car. Your car is just a car, drives you around, drives passengers around, has a little bit of cargo room. But let's say you want to tow your caravan. You can't unless you had a tow bar, which is that extension. So with that tow bar, we can add a caravan, we can add a boat trailer, we can add all sorts of things, just even bike rack. So a virtual switch extension is a part of the programming code which allows us to add to it. So it allows third-party vendors to create virtual switches. What do I mean? It means like if you're a company like Cisco, we all know Cisco makes switches, don't we? We all know Netgear makes switches. We all know that there's tons of companies out there that makes physical switches. But guess what? Those companies can now make virtual switches as well. So for example, Cisco, we can actually get a Cisco, Nexus 1000V switch, which is a virtual switch in our Hyper-V and vSphere environments. What does that mean? It means that all the same commands that work on physical Cisco switches will work on these virtualized switches. All the quality of service that's in the physical world can be extended into our virtual world. So you can manage virtual switches by using the same toolset that you use to manage physical switches. So basically, if you use a web interface to manage the physical switches, because they got these third-party extensions, you can manage the virtual switches as well. If you use a command line tool, same thing. Virtual machine MAC addresses. So we all know what a MAC address is, hopefully. Okay, so we all know it's basically the addressing that's part of your network card, and then on a physical machine that's written on your network card, half of it is a vendor code, half of it is unique. On a physical machine, pretty much you don't need to worry about MAC addresses. It's there, it's unique, it's different. But on a virtual machine, we know that we can copy a virtual machine, we can clone a virtual machine, we can do lots of things with a virtual machine. And when we do copy a virtual machine, this MAC address potentially could be exactly the same. So here's an example of Virtual Switch Manager, and we can actually define the range of MAC addresses that we can allow on here, or we can actually manually go change the MAC address of a virtual machine. Virtual network adapters. Properties of a network adapter include the switch, the VLAN ID, and the bandwidth management. Features of the network adapter includes the MAC address allocation, DHCP guard. DHCP guard basically is a way of protecting yourself against rogue DHCP servers. Okay, a router guard against protecting yourself against a router that's pretending to be a router or an alternative router. There's also port mirroring. Port mirroring does exactly what it says. Instead of actually, if you've got two virtual machines which are doing the same job, instead of the traffic just going to one of them, port mirroring means that it mirrors the same traffic to two different ports to the two different virtual machines. There's NIC Teaming, which I spoke about before, where you can combine multiple physical network cards to be working together, and that provides obviously load balancing and redundancy. Okay, if one NIC fails, that one still works. If you've got two 1 gig network cards, you'd suddenly have 2 gigs of bandwidth. So NIC Teaming provides redundancy and aggregates bandwidth, and is supported at the host and virtual machine level. So at the host level on the HyperV, as well as inside the virtual machine on the Server 2016 virtual machine. NIC Teaming in virtual machines requires multiple virtual network adapters, but to be honest, that does nothing if you don't have multiple physical network adapters as well. So it must be enabled in a virtual network adapter, can then be implemented in a virtual machine OS if supported. But to be honest, virtual machine NIC Teaming is not as important as physical or host machine NIC Teaming. All right, guys, so this is the end of the PowerPoint presentation. What I want you guys to work through is the worksheet 8, which is the install and configure Hyper-V. There's a couple of tricky points, so you'll have to edit the VMX files for your server to allow for this nested virtualization. If you actually don't get that syntax right, it might not work. So obviously just be a little bit careful. Don't try to copy and paste it in as much as you would feel like you need to, because it's so much easier. Because sometimes when you copy and paste, you end up copying the wrong extra characters, or the characters get copied from a Word document to a ASCII text. They might have different characters. Okay, so even as much as you want to, don't copy and paste, type it out and check your typing every character if things are not working.